Congratulate workshop participants. We are glad that in this difficult period for Ukraine, we have the opportunity to report at this conference. We want to present a report on the topic, the impact of electromagnetic pollution on the phytocenotic diversity of the transcordon region. The electric power industry is a source of noise, vibration, and electromagnetic pollution of the environment. Electromagnetic radiation is considered the cause of chronic fatigue syndrome, which was diagnosed in people at the end of the 80s of the 20th century. Under electromagnetic pollution, the decrease in reproductive potential, higher mortality, and increased migrations among animals are observed. Plants are the primary technogenic influence recipients, and they reflect the level of environmental anthropogenic transformation. The plant community's phytocenotic diversity is a key marker that reflects the ecological state of the ecosystem, its balance and stability. Vibration pollution affects the physiological qualities of plant seeds, which leads to their germination degrees. That's why the issue of the electric power industry facilities' impact on natural phytocenosis has not yet been studied and requires the attention of ecologists. The purpose of our research is the analysis of the plant's community species diversity under the influence of electric power facilities in the cross-border region of Ukraine and Romania. The main tasks of the research are to analyze the probable impact of the electromagnetic field on plants, to investigate the species composition of phytocenosis, to study the dominant plant species in the areas affected by power plants, and to find out species that could be used as biological indicators of the electromagnetic pollution. The research was conducted on the cross-border territory of Ukraine and Romania in the monitoring areas under the influence of electric power facilities. The monitoring network included 46 points in the immediate vicinity of the radiation source, a radius of 50 meters. The level of electromagnetic and noise pollution was measured. An analysis of the species diversity of phytocenosis within each monitoring point was carried out. Plants were photographed on a test plot with an area of 25 square meters. While the phytocenosis had the form of a narrow strip, the transects of 4 square meters were laid. The taxonomic characteristics of each species and life form were determined according to the generally accepted method. Monitoring points were established in the next locations: Yaremche, Yasynia, Rakhiv, Dilove, Tyachi, Teresva, Nizhny Avsha, Solotvinom, Sokernica, Hust, Lipcha, Nizhny Bystry hydroelectric power station on the Terebla River, Vyshkiv, Shevchenkove, Stary Bohorodichany, Bushtin. The phytocenotic diversity was determined as a percentage at each monitoring point. The plant diversity in the monitoring area with the largest number of plant species was taken as 100%. The coefficient and class of constancy of each plant species were determined according to the following classification. All plants were divided into 5 vitality classes and 3 representative classes: high, middle, and low. The results of phytocenotic diversity studies under electric power plants in plants demonstrate the following. The largest number of plant species is represented on the wind power plant territory in Shevchenkova village, 34 species, and on Bohorodichany experiment area, 32 species. The lowest number of plant species, 4 species, is represented on one of the experimental sites in Yaremche town and on the territory of the private sector in Tyachi village. By high phytocenotic diversity, more than 75% is characterized the first experimental site in Yaremche town, the experimental site in Dilove village, and Nizhnya Tesa village. In the areas affected by electrical installations, 10 of the 47 identified families are the most common. Staratsa represented at 45 monitoring points, Kabatsa 39 points, Rosatsa 26 points, Apiatsa 33 points, Rospoatsa 26 points, Lamiatsa 25 points, Ranunculatsa 24 points, Urtikatsa 16 points, Lantaginace 23 points, Polygonatsa 17 points, All other families are marked by a low representation in the biological monitoring system of electric power facilities impact. They are present in the number of 1 to 7 monitoring points. In the areas impacted by electrical installations, largest number of species is represented by the families Asterace, Rosace, and Poace. Liudmyla family is represented by 14 plant species, Apiace 12, Fabace and Polygonace 9 species, Ranunculace 7 species. Other families are represented by from 1 to 5 plant species. Among 196 identified plant species, 179 species belong to the first class of vitality, 12 species to the second, and 4 species to the third class of vitality, which in percentages is 91, 6.5, and 2.5% respectively. Herbaceous plants dominate in the all investigated points except for the area on the edge of Jachi village, and they make up from 74 to 100% of all live plants forms. This is explained by the high level of herbaceous form survival due to the peculiarities of structure, physiology, and individual development. Shrubs are represented in 11 out of 46 monitoring points, and they make up from 5 to 25% of all life forms, and trees in 20 points and make up from 4 to 75%. Among 196 identified plant species belonging to the third class of vitality have the highest representativeness. Achillea millefolium, Trifolium protensa, Trifolium repens, Daucus carota, and Vallis perennis are the dominant plant species represented in 46, 48, and 50% of the experimental points, respectively. The second vitality class includes the following plant species: Taraxacum officinale, Centaura yasa, Lanceolata, Sonchus arvensis, Calamagrostis epigeus, Dactylis glomerata, Ranunculus acris, Menta longifolia, Tanacetum vulgare, Artemisia vulgaris, Urtica dioica, Lotus corniculatus. These species are represented in the amount of 20–40% of experimental points, are characterized by the intermediate biological indicative opportunities, and can be used in monitoring studies of electric power facilities' impact on the environment. 196 plant species were detected at monitoring points under the influence of electric power facilities in the Ukraine-Romania transcordon region. Among them, 179 species belong to the first vitality class, 12 species to the second, and 5 species to the third vitality class, which is percentage is 91, 6.5, and 2.5% respectively. Under the noise and electromagnetic pollution in plants, 17 plant species reveal middle representativeness and 180 species low representativeness. Among 47 identified families, Asterace, Rosace, and Poace families are represented by the largest number of species. In all research points, with the exception of one site, herbaceous plants dominate, which make up from 74 to 100% of all plants life forms. Shrubs are represented in 11 monitoring sites out of 46. They make up from 5 to 25% of all life forms, and trees in 20 sites and make up from 4 to 75%. Achillea millefolium, Trifolium protensa, Daucus carota belong to the third vitality class and are represented by 46, 48, and 50% in the experimental points respectively. These species reveal the highest biological indication capacity, can be used in monitoring studies of the system's environmental state under electromagnetic and noise influence. Taraxacum officinale, Centaura yasa, Plantagola ceolata, Sonchus arvensis, Calamagrostis epigeus, Dactylis glomerata, Ranunculus acris, Menta longifolia, Tanacetum vulgare, Artemisia vulgaris, Urtica dioica belong to the second vitality class and are characterized by the intermediate biological indicative opportunity. The remaining 180 species belong to the first class of vitality. They cannot be used as phytoindicators of the ecosystem's ecological state under electric power facilities influence. Thanks for your attention.